Well, well, what has the cat dragged in today? It's a video tutorial on stealth games, specifically character controllers. Now, when I say character controller, I mean a very, very simple character controller. We could very, very easily spend 20 plus hour long videos on creating a character controller and the necessary camera control as well that goes into making what people expect of a modern day third person character controller. We're obviously not going that far down the rabbit hole. What we're going to create is a very basic but functional third person tank controller. Think like really classic Resident Evil, like the original Resident Evil 1, where you could move forward, you could move backwards, and you could turn, and those were your controls. That's what we're going to be doing here today. Nothing fancy, but functional and easy to implement. The first thing that we're going to have to do for this implementation is make sure that we have our player selected, and we are going to have to add in the character controller component. Now, I am not the world's biggest fan of this component. In fact, I could probably go on a 10-minute rant about this particular component, but I won't because that's not the point of this video. The biggest issue that I have with this is that it does a lot of stuff under the hood, so to speak, where we can't access it. Specifically, this is creating a hidden kinematic rigid body collider. There's no way to access this rigid body. There's no way to make it non-kinematic, but it is there. Otherwise, certain messages wouldn't get generated. But they don't let us have access to that. This character controller is fine for simple projects, simple prototypes, but honestly, for any commercially released code, I would either write my own or most likely use a purchased character controller from the Unity Asset Store. And there's a reason why you have to buy all of the good ones, because these things are a stupid amount of work. But all that said, the character controller component will work well enough for our purposes. Let's adjust some values. As we can see from the scene view here, our wireframe showing where the capsule is for this character controller isn't exactly matching the character here. So we need to change this a little bit. Now, through experimentation, the values that I have found that works fairly well for this is to set the height to 1.9, and then to set the center to 0.9. And that works pretty good. Actually, center to 0.95. There we go. That works pretty good. That fits in fairly well to the system. And yeah, you can tweak this. This is where some of the time loss could start coming in for doing fine-tailed tweaks. This is not something you want to lose yourself in at the start of the project. So you can spend a lot of time fiddling around with these values, trying to get something that is exactly right. So like right now I've got a height value of 1.8 with a center value of 0.9 on the Y, and that fits a little bit better than what fits a lot better than what the original values were, and a little bit better than the value that I first suggested. You can potentially spend a lot of time tweaking numbers like this. It's an important thing to do and to budget time for, but also don't get too wrapped up into it. Now, the other value that I am going to adjust, because otherwise this radius is a bit too large, so I'm going to have that radius down to 0.25. Now, does this mean that the arms will be outside of the radius when they're down by her side? Yeah, it does, but that's not a big deal in this particular case. And that's all the customization we're going to do with the character controller. The slope limit and step offset are not going to come into play for this video, so I'm not going to get into what all of these additional options mean, other than to say leave them alone, because you could potentially really mess things up if you screw with them. With the character controller done, we are now ready to start writing some code. So I'm going to go into my scripts folder. I am going to right-click, create C#, and I am going to create the player controller. And then I will double-click on that code file to open it up in Visual Studio. Again, mine opens reasonably fast. Do be sure to pause the video and wait for Visual Studio to fully load up before continuing on. Now, what information do we think we are going to need to get this to work? Well, there's a couple of real low-hanging fruit that should be fairly easy to come up with. I've mentioned that we're going to have rotation on the character, right? Well, we need to know how fast can I rotate. And obviously, since this is something that I want to be able to tweak in the inspector, I am going to make it public. So I'm going to say public float rotate speed. And I will set that initial value to 90. Again, the F is not necessary, but it's a good idea if you're using floats to be explicit that this is a float value. Remember, we're expressing this in degrees per second, so I am saying that I can turn 90 degrees per second so that it would actually take me a full 4 seconds to fully spin around in a 360-degree circle. The other low-hanging piece of information that I know that I'm going to need and exposed in the editor is how fast do I move. So I'm going to say public float move speed, and I am going to set that to a default value of 5. I have found that a move speed of 5, when you're using Unity's sort of default implication of 1 Unity unit equaling 1 meter, tends to work pretty good. Now, there's a couple of pieces of information that we're going to need that might not be quite as obvious. One that's a bit more obvious than the other is we're going to need access to that character controller component. So we come back over here and we look at our player character. We have this character controller component, and we're going to have to interact with this in order to move the character. So we need a reference to this component. Now, lots of ways that you can grab that reference. I'm going to set it up through the inspector because I can just, it's a one and done. I can just do it and be done with it. So I'm going to say public character controller. The other thing that I'm going to need access to is I'm going to need access to the animator component here in order to be able to control how the animations are playing. Again, I'll go back to Visual Studio and I will say public animator, animate lowercase a, thank you very much. And I'll link that up again in the inspector. While we're not going to put anything into start right now, don't remove the start method because we will be coming back and putting something in start. Update. What is it that we need to do every frame? Remember, it's a good idea to write out in comments, sort of like the broad strokes, just in regular old English, what it is that you want to do. So one of the things I need to do is I need to rotate the character. Now, what do I need to do to rotate the character? Well, I need to get horizontal. If I can type correctly, that would be lovely. So I need to get the horizontal axis. And then I need to scale that by my rotation speed and time.delta time. I'm just going to do, shorthand scale by speed and time. Because when I get the horizontal axis, that basically gives me the direction I'm turning. Multiply that by speed and time to get the actual amount that I'm turning in this fraction of a second. And then I actually need to apply the rotation. I can sort of go through and do the same steps with moving. So the other thing that I need to do is move the character. How am I going to move the character? Well, I'm going to use the vertical, which is bound to W and S. So I am going to get vertical. I also need to know which direction I need to move. Because like rotation doesn't matter. I just rotate that degree amount. But movement matters. It's like depending on the facing of the character, that depends on which direction I need to move. So get vertical is also in a way getting the direction. Am I going forwards or backwards? But then I also need to get, well, what is forwards and backwards? Which, literally there is a forward property on the transform that we'll hook into. Again, I need to scale by speed and time. And then I need to apply the motion. So another step here. I need to update my animation. And looking at this, I realized it's like, well, what am I going to use for the animation? What do I need for the animation? Animation's on a scale of -1 to 1, right? What is it that's getting me -1 to 1? Oh, that's my vertical. So maybe instead, after I get to my vertical axes, that's when I should update animation. Because the animation update doesn't care about my forward direction. It doesn't care about how scaling by speed or scaling by time. All the Animator controller cares about is what is the magnitude of my forward momentum. Am I walking forward? 1. Am I standing still? 0. Am I walking backwards? -1. That's all the Animator cares about. So, you know what? Let's actually move that one there. I strongly encourage, as a new programmer, someone getting used to writing C# code, that you do something like this. Because it really does help lay out your thoughts of what do I need to do and what do I need to do that. And it just makes it flow a little bit easier, I have found. Okay, rotating the character. Let's get this done. I need to get a horizontal. We've done that before. And eventually this is going to be a rotation amount. So I'm just going to say float rotate amount. And I'm going to start this off with input.get axis horizontal, which should be old hat by now since we've done this in a couple different projects. I need to scale this by speed and time. Oh, and I have my variable misspelled. There we go. That's how you actually spell rotate. I'm going to use a shortcut times equals. Remember, this is the equivalent of saying rotate amount equals rotate amount times blah, blah, blah. Just saves a little bit of typing. I need to multiply this by my rotate speed. And then I need to scale that by time.delta time. Because remember, we want this expressed in fractions of a second. We don't want this to be dependent on frame. We want this to be frame independent. And then I need to apply the rotation. How do we apply rotation? Well, remember, the transform component is where we always go to if we have anything involving moving, scaling, or rotating. In other words, the transform properties of an object in 3D space. So lowercase t transform dot. Now we've got a couple of different versions here. The version that we want is rotate. Rotate around is a deprecated method, meaning it will eventually go poof. So don't use rotate around, use rotate. And there's a couple of different versions. The version that we are going to use is the one where we specify which axis we're going to rotate around and then how much we're going to rotate. We want the Y because we want to be spinning in place. If you think about it, if I rotate it around, if you put your arm straight up in the air, that's your Y axis. And if you rotate your arm around with your body, that's rotating around the Y axis, right? So that's how you change facing. So I am going to use vector3.up. You could also do a new vector here with 0, 1, 0, but vector3up's already nice and defined. And then what is the angle in degrees? Always important to pay attention to that. Are we talking radians? Are we talking degrees? This one's degrees, which of course is my rotate amount. We have a testable fragment of code. Let's test it. So I'm going to save. I'm going to hop over to Unity. Hurry up and wait for the compiler. Now I haven't attached my code over here yet, so I'm going to go ahead and yeet that over there. So now I got player controller. And even though we're not using them yet, I am going to go ahead and link these two bits up. So I'm going to mouse over the character controller title bar, left click drag onto that slot. And I'm going to do the same thing with animator. I'm going to left click drag on the animator title bar, drag it down, release it. So now I have those two added in. You could also use the pickers, and that would work as well. All right, I'm going to hit the run button, and I should be able to use the A and D keys to rotate. Now, there's two issues that we will notice here immediately. One, my camera angle sucks. Two, I appear to be a magician and I'm hovering above the ground. The camera will fix now. We'll come back and fix that little floaty bit in a moment. Now, I want this to be an over-the-shoulder style camera. So what I'm going to do is first I'm going to switch this to, nope, that is not the right button at all. I'm going to switch this to full screen. So I'm just going to maximize the screen for a moment, so I have a better idea of what this view actually looks like. And I'm going to use Facade and Q and E to get sort of a good over-the-shoulder, maybe slightly off-center camera angle on my person here. And get out of maximize mode. So go back over here and uncheck that. And then, remember, this is my editor camera. My main camera still shows here. So I'm going to select my main camera, and I am going to do a Control-Shift-F, which if you go into Game Object, that is Align with View. That aligns whatever the selected game object is to the editor camera's location and rotation. So if you watch, Control-Shift-F, boom. Now, I want to make sure that the camera follows the player, because at the moment it doesn't. If I hit the run button again, I am not following the player's motions. And all I need to do here, since this is a very basic setup, is I am going to make the camera a child of the player. So now, as I rotate the player, the camera comes along for the ride. All right. Let's get the movement finished, and then we'll take a look at the floaty issue. So going back to our code, let's move the character. Get the vertical. Now, eventually, I am going to get to how much do I want to move. So I am going to say float move amount, and I'm going to set that into input dot get axis vertical. Update the animation. Now, even though this variable name has nothing to do with movement speed, so to speak, it still contains the value that I need. So I'm just going to toss it into the animator. So I'm going to say animator dot. Now remember, we have that property that we set up. I'm just going to hop back to Unity here real quick. We have that property that we set up in the animator called move speed, capital M, capital S, no space. This is case sensitive. The string that we put into the code has to match this perfectly. So what I'm going to do is I'm going to use the set float. There's actually a variety of set commands. You can set bools, floats, and triggers, which are pretty much the only things that we can set for animators, at least. So I'm going to say set float. You're going to pass in the key, or actually you can pass in a integer ID. I prefer to use strings because that's a lot clearer to whoever's coming behind to look at this code what you're setting. So I am going to set the key move sped. No, I want move speed. Thank you. And the value that I'm going to set it to is move amount. So again, it's animator.setFloat, the string move speed, and then the variable move amount. So now my animations will play correctly. Now I need to set what is my forward. So get axis or move amount is currently either going to be 1 or -1 or 0. So if I take that and I multiply it by my current forward vector, in other words, the vector that is pointing in the direction defined as forward, which again, remember for Unity is the local z value. Again, for visualization purposes, let's hop back over here. I'm going to be in scene. I'm going to change my tool handle to local mode. And so regardless of this character's rotation, that blue forward Z arrow is always going to be pointing in the direction that is forward, relatively speaking, to this model. That is what I need to get. I'm going to switch that back to global now. So what I can do, so I can say move amount times equals transform, because again, this is positional information, dot forward. And this is also why I do things live, because occasionally I'm going to make mistakes. And I want you guys to see what those mistakes are. So I have red squiggles of doom right now. Why do I have red squiggles of doom? Well, first thing you always do when you get red squiggles of doom is mouse over the affected area. Cannot implicitly convert type UnityEngine.vector3 to float. Oh, right. That's why. Forward is a vector 3. Also, consequently, when we actually go to use the motion, it's going to want a vector 3. However, this is a float because, I mean, that's what input.getAxis gave us. So what we can do, what we have to do basically at some point is get a vector 3. So what I'm going to do here, and there's a dozen different ways we could probably approach this. What I'm going to do is I'm just going to go ahead and create a new vector 3. I'm going to call this move vector, for lack of any other better name. And I will set this equal to the transform.forward times the move amount. Because I want that -1, 0, 1 multiplication to determine am I going forwards, backwards, staying still. Then I need to scale this by speed and time. So I'm going to say move vector times equals move speed times time.delta time. So now I have that forward vector that's pointing in the correct direction, forwards, backwards, or nowhere at all. Scaling it by my move speed, scaling it by time.delta time. Now I can apply this to the character controller. So I can do controller.move, and we can apply the move vector. We have a testable piece of code. Let's test it out. Pause the video here if you need to make sure that you've got all the code entered in. And with that, let's get on with testing. Hop over to Unity, let it recompile, take a quick drink. I mean, literally, I did take a quick drink because my throat's killing me today. And let's see how this works. So I can still rotate just fine. And if I press and hold W, I move forward, and I can turn left and right while moving. I cannot walk through the wall. I can walk backwards. And I fall off ledges. Lovely. And there we go. We have a functional character controller. Now, I know this particular video is getting a bit long in the tooth, but there's something I want to fix real quick before we move on, and that's the floatiness. The whole hovering in midair. And this is a problem that illustrates what happens when you kludge together a bunch of different assets from a bunch of different sources. I have Unity's character controller that was developed in isolation. I have Synty Studio's model, which was developed in isolation. I have Kevin's animations, which were developed in isolation. You get the point here, right? Smashing all three of these things together, you're bound to get oddities. I don't know what it is between the character controller and Synty Studio stuff, but if I use the basic character controller with Synty Studio stuff, the model hovers about 0.1 meters off the floor. It's a fairly simple fix, if a slightly aggravating one. What we need to do is I'm going to select the player, and I'm going to look at the Animator component. There is an avatar defined for this. And avatars for animation just simply define how the bones and such actually map out to the system. So if you go into the root, you'll find the hips and spine and all sorts of bones and such. The avatar is sort of like the glue that, links together the mesh with the animations. If you left click on this, and this works for any picker field, remember, if you left click on the name of the asset, not the picker, because that obviously brings up the picker. If you click on the name of the asset, it will select it in the project and it will ping it. You can see it's pinging character's avatar right there. So now I can select this. I can click on Configure Avatar. I can select the root because we are definitely not messing with this monstrosity of information. I can select the root, and on the inspector panel down here, I can scroll to the bottom, and I am going to set this to -0.1 on the Y. I'm going to apply, and then I'm going to click Done. Now let's see what this did. Save my scene just to be paranoid. Hit the Run button. And there we go. I am no longer floating in the air. Now, if you're really sharp-eyed, you can notice that, yeah, okay, I'm still hovering ever so slightly above the floor. I'm not going to worry about fixing that. And there we go. We now have a fully functional, if basic, character controller that we can use to navigate around this level. Next up, we'll get some enemy action going and start building up the guards so that way they can begin to detect and chase after our valiant player. As always, if you like this video and you think you learned a bit from it, a thumbs up would be appreciated. And if this was just one colossal waste of your time, well, the thumbs down button is right next to it. Until the next video.